Oh, yeah.
Hi, everyone. I hope you enjoyed the talk from Sergey, and it's time to start our next talk. It will be delivered by Ana-Maria Mihalceanu, and she's a custom application development enthusiast and co-founder of Bucharest Software Craftsmanship Community. She's a constant adopter of challenging technical scenarios, so make sure to ask your questions, maybe share your use cases, and get great advices from Ana-Maria. Some of her old experiments are available on DZone. And from other passions, maybe out of technology, she can on knowledge hunting through reading, and she grows her fashion skills through shopping. Ana-Maria, I think we can start, and maybe you can tell a bit more about your upcoming talk, or just start with your presentation.
Yes, thank you for having me. Let me share my screen. Yeah, I think right now it's starting sharing. Okay, so first of all, thank you for having me here at JFuture. We're going to talk about how to let Kubernetes batch that for your Java application, because we're at a Java conference. Alina has introduced me already, but apart from what was already told, you should know about myself that I started and I'm still Java at core, but I also enjoy untangling the mysteries of Kubernetes, and I certified the second passion I have with OpenShift and Linux for Nations certifications. And as Alina already mentioned, I'm sharing some of my experiences in Romanian with the local community here in Romania, the Bucharest Software Craftsmanship Community, which I co-founded together with Victor Rente. About the talk of today was the fact that we want to reimagine something considered old in a new context. And maybe for most of us, batch applications are not an old concept, but I had the pleasure to talk with junior developers or people that are new to the branch of the development. And when they heard about batch applications, they were a little bit reluctant and thinking that this is something you're doing in the old ways, before the cool microservices came out and help us in making distributive systems all over the place. And perhaps these kind of applications do not have a place in our modernized apps. But in today's talk, we're going to talk about how they still have a place and how you can modernize something you already had. Some historical facts. Well, batch processing, revolutionized, in my opinion, with the GSR 352 specification that was part of the platform. And for me as a developer at that time, it meant that it defined a programming model for batch applications, plus a runtime to run and manage batch jobs. I have experience with Java 6, Java 7, 8, and so on. So for me, it meant a lot in terms of help for processing, because it meant a more standardized way to create these type of batch applications. And for those of you who hadn't had yet the pleasure to create a batch application, I'd like to give you a quick intro that a batch application is typically an application that is always performing a bunch of operations on a lot of data and performs those operations in bulk. It's something considered automatic. It's long running, and it typically, as a developer, you would have considered that part of application as separate from the business, the core business of your web or, let's say, desktop application of Java. And it was something that was, processing things in the background, making those ready and available for your actual application that the users enjoyed. And one more thing, it could be this kind of batch application can be on demand or on a predefined schedule. So on demand meaning maybe before saying, hey, start this batch application, you'd have received an email approval, or you would have waited for some kind of approval before starting such an application, or running on a predefined schedule, let's say every day at 4 p.m. So When you're writing a batch job application, you have to have in mind a few capabilities of this batch job. So things I've learned is that always when you are creating a batch job, you have in mind that you're going to process a large amount of data. So you don't employ such type of application if you have like a small amount of data that you need to process from one place to another. Again, as specified earlier, it can be initiated on demand or can run on a predefined schedule. And another good thing that I've learned is that you should log at each computation and data manipulation you're using. The reason being is because you are performing some operations on a bulk of data, on a chunk of data, and sometimes these operations can take longer time. So you should also constantly check those long-running operations, and you should make sure that they're executed in a certain amount of time, an expected amount of time, and log what is going on when you're making that computation and transformation. And the reason behind that is because some data is not always in the format that you are expecting it to be, and might come in a faulty format. So you should be able to check, verify what's going on there, but you should also give the ability to your batch application to recover and restart when a failure occurs. So if something happened when you are processing a chunk of data, you should have the ability to reprocess that chunk of data and manipulate it in a good way so that you are not affecting some data and send some faulty data to your users. And keep these capabilities in mind because we're going to use them also in the further examples in the presentation. I spoke to you about JSR 352, but if you're looking to the anatomy of a batch job, it all started with the job repository, which contains the jobs that need to be run. And the job launcher is the one who's pulling the job from the job repository and is putting the job to work. Every job contains one or more steps, and the steps can be either chunk or task-oriented. So there are two types of steps in case of a Java batch job. But any step should contain one item reader, meaning how you're going to read the data from the place you want to process from, how you're going to process the data, the item processor, and of course, an item writer, how you're going to write the data to a specific place. And another important part of this batch job is the fact that this kind of batch job is put together thanks to a job specification language, JSL, which is typically an XML that is defining the steps and the type of item reader, processor, and item writer. This is pretty much it about the Java side. So now let's see some code, because we kind of talked a little bit about the batches. And if everyone sees my screen right now, we're going to start with the JavaEE application. My JavaEE application is not exactly as old as you might expect it. It can be run on a Liberty server. But I was thinking like to transform it. So let's look a little bit on its description. It has this very nice description of what actually it runs. So what's the job? And I call it's a simple job. And the simple batchlet is being referenced here, the one from here. And it's just, incrementing and waiting some time to write some data and incrementing some data, and writing it back. So it doesn't do anything very, very smart from this point of view. But it uses the batch specification to do this job from time to time, let's say. So this is pretty much JavaEE based, can be very shortly ran on a Liberty server, or if you want to try it on a WebSphere or any other application server, please go ahead. I made it as simple as possible so you can port it across the servers, the application servers. Of course, it has a web XML. It has a configuration for my Liberty, the server.xml. All is good. So if I were to think to move this kind of application to my part in the cloud, I would firstly think and how to port it in terms of containers. So I would need to create a Docker file. Now, luckily, I don't have any dependence to a database or any other third party. So I'm just like running on my own for this simple batch app. So making a Docker file for a simple app as this one, it would be like creating a from, because I'm using Maven to build my app. I'm going to use the Maven from image for JDK 8, and I'm going to say simple batch application. And as I would have done it as a developer, I would have just said ambient clean package, and that's it. But right now, I'm instructing Docker to do that for me. Since I need to run this application, so I'm building my app, but I also need to run it. I also need to have a runtime, and I'm going to use the image, the from Open Liberty image that comes with Java 8 on it. And I'm going to take the results of my previous build from here, as you see from NVM build. The word that was resulted there is being left in the drop-ins of the runtime. And after putting that into the drop-ins of the runtime, I'm copying the server.xml, the one I had earlier, and given also to the build, into the config part, so that I am configuring the runtime as I would have had it on my local. Now moving forward, so let's say we have Docker files, and this is going to create a Docker image. Once I'm going to build and tag it, we want to use the job specification from Kubernetes to put the orchestrator to work for us, and to not have any more that situation when we have to be involved in running things. So what I'm going to do, I'm going to have a simple job object of con jobs. I'm going to make this bigger. Let me give it a name. I'll say single odd job, because that's what it's going to do. I'm going to say, let's generate the name, just to make sure that I don't have any other jobs running over there. The image that I'm going to use is the simple JEE batch, the 1.0 version. I already had it built. I'm going to say simple batch, and I need to remind myself what was the container port from server.xml, so I would say 9080. So I'm going to access it via 9080. Cool. But looking at this, I see that I'm going to tell to my orchestrator, okay, run this image and do your job. But if I would have had to run my job, I would have had to go to my browser and would have had to invoke a servlet that would have started my job. So I'm thinking right now, I have to tell Kubernetes to do that as well, because I don't want to get involved anymore into running commands or anything else, except for the one that is, starting the job of Kubernetes. So what I'm going to use is a sidecar container that is helping me with the curl command. And what the sidecar container is going to do is going to execute a curl against my servlet, and is going to run the job with specific parameters, and that's it. And now putting this to work, because it also has to work, so it's all good. Okay. Say kubectl create -f. It's single pod job YAML. So the job was created. Now let's go and see what happened at Kubernetes level. And if I'm going to go to, kick me out. So looking at my jobs, at the fact that I had the single pod job, and it created my job. Now let me look at my pod. How is it going on? I'm going to see one thing. So the actual pod that runs my server, my application, has started doing its job. So that's the simple batch. It's logging from simple batch. And the sidecar one, it has a little problem, but it will work out. It's going to be the one who's going to execute the connection at the command against my my application. So this is how you can make it work and execute things totally unaware and actually totally decoupled from your actual Java application, but putting Kubernetes to work that for you. So not doing this necessarily on demand and going through all the commands by yourself. Now, going a little bit forward with the presentation, what we saw earlier regarding the modernized batch is firstly the fact that we have tried to decouple the app from the scheduling framework. This is something that was really wanted for a long, long time, to have this decoupling from the actual app that does the work from the environment, so that you have that easy portability of even of your batch application. By putting Kubernetes to work with your together with your batch application, you are managing to have that isolation of atomic units of work. So you're putting the pods of Kubernetes to be that isolated atomic unit of work, and you do not care about what operating system is around your application and all those sorts of things that used to be an impediment in the past. And secondly, you can also have the ability to define that unit of work reliably, and then you can shut down the container. What this means is that once your job resource in Kubernetes has executed and has done its job, the pod itself is going to appear as terminated with success, and everything is going to work as designed, and that's it. So if you need to run again the batch job, you would need to instruct another Kubernetes object to run that work for you. And that's really good because you have the ability also to monitor at the level of the of Kubernetes what has happened over there, and it's way better to overlook over the restarts and the recoveries that happen when failures occurred. Now, there are two approaches in regards to Kubernetes jobs. So the first one is having one job per work item. This option works really, really well when you have a complex task that needs to be recorded and has to be scaled independently. And it works well, but you should know that it has an overhead of creating Kubernetes jobs. Because it was the platform to manage a large amount of jobs that are consuming resources. And this option is, as said, is useful when you need to scale independently each job. But the second option is to have one job for all work items. This option is right when you have a large object of like a large number of work items that they do not have to be scaled independently or traced independently. Or in our case, you already had an application that was using the batch framework, so there was no need to define one job per work item. So this was our scenario. By looking a little bit further, our scenario was looking also to have the completions and the parallelism value set to 1. So it was creating just one pod. That's why it was called a single pod job. But you should know, besides the single pod job that is executing atomically and only once your job, it can also be called like an emergency job. When you need to fix something, you're just starting it whenever you need to fix something. There's also the fixed completion count jobs, meaning when you can predefine, or actually you make your own math of how many work items can be ran in parallel in order to get to that done of that specific job and make it faster. So you need, when you're dedicating more pods to your process in order to do the job in a faster time. And the last but not least is the work queue jobs, the ones that require the pods to coordinate among themselves. So they're like, you could say that they're like fixed completion count jobs, but they also require coordination of what the pods are doing amongst themselves so that they don't go and overlap in terms of data that they're processing, and they're altering the same data, or you get to in a big trouble when it comes to processing of the data. We're going a little bit further and see how the fixed completion count jobs are working with the single example that is on a Spring application. So let me close this one. And the second application, it's called Cat Adoption Batch. What this small app does, it reads the data from an XML that has information about cats that can be adopted. and it processes that into a CSV format. Let me just make this a little bit, show dependencies, and make it better. Okay, so for this one, the actual Java application is written with the Spring, I think the version 3. And it's using the batch framework, older version as well. This app is processing as XML. It creates a report in the CSV format, and that's it. So it's using that transformation that we were talking in the beginning of the data. In this case, it's not that much data because we don't have that much time for processing. Let's look a little bit how this is configured. So as you can see, I wanted to use a Spring as it used to be with XMLs, with defining bins and XMLs and all these parts. And I configured my job separately. And you can see here that my job, the report job, is kind of having the following configuration. It has the reader, that item reader, which in this case is an XML item reader. I'm reading from an XML. I'm writing to a CSV, and my processor has a business logic like if a cat is having, I think, less than 1 month at the shelter, it cannot be yet adopted because it's not fully grown to be adopted. So that's it. And my filter report processor is something that I implemented on my own. So it's my own bean. The same for the job execution listener, while the XML item reader and the CSV item writer is something that I'm using from the Spring-batch platform itself. If you're looking to this, how this application is looking like, so this was like the before state. And we're going to how the modernized part of it would look, because now the modernized part of Spring, you would think naturally to Spring Boot. So what bringing this to Spring Boot meant was actually keeping a lot of the things that I used to have. So let me show you the dependencies as well. And split this vertically. Cool. Make this bigger. Okay, so I kept pretty much the things that I had before, didn't alter anything. What I modified was how my cat adoption batch application is looking like. I have to bootify it, to put it to Spring Boot. And since I had a lot of XMLs to configure my job, I moved everything into a configuration in the batch config that is going to work further and configure my app. So I'm not having any more XMLs to define my batch configuration. Everything is being handled from here. And the only XML that you're seeing right here is that for a local test. So it's nothing fancy. So this is the first part of the, let's say, modernization. But secondly, there comes an idea like how would I would be able to run this in using an orchestrator or using Kubernetes. So pretty much like we did it before, we're doing the same thing with it's also built with Maven. So I'm just using the same from specification as I used to have before, and the same build instructions and so on and so forth. I'll just say cat adoption batch. But different from the other one that was running on Liberty, this time I'm going to use a different runtime. So I'm going to use the OpenJDK directly runtime, and I'm going to use the java-jar customized command in my entry point.ch. So again, I'm copying the results of my build, in this case, a jar application, and I'm using the entry point to run my app. And as we had in the Docker file earlier, we used to have to run the application using a user, and we want to make this securely. We're going to have a user here as well called app user, who is going to be instructed to have the ability to run this container. So this is pretty much it at the Docker file level. If you're looking up, we want to use the fixed completion count jobs feature of Kubernetes. Let's go to K8s. But firstly, as different from the other one, this one has an input and an output. So we need to store those files somewhere. And specifically talking about storing files, in my resources and application.properties, you can see here, I've defined that my input.xml should come from somewhere given by the environment, which was passed to input XML. And the path to output CSV is also something that it has to be from the environment. It has some defaults, but it can be overwritten from the environment part. So what I'm going to do, I'm going to provision, so I already have provision for my environment persistent volume, where I will write, I will access data and write my data. And I'm going to be able to write to this volume and access data inside this volume via persistent volume claim resource. And this is how I'm going to put everything at Kubernetes level, so no more interaction with file-based system, because that would not make the sense in terms of an orchestrator. So let's look at the fixed completion job.yaml. How is that looking like? And making it a little bit bigger. So the XML transformer to CSV is pretty much looking like the other one in terms of configuration. Now, the difference is that the completions is being increased to 4, meaning that the job should run 4 pods. And run those 4 pods like this, like 2 pods should be ran in parallel. Once the first 2 are done, the other 2 should be ramped up to process the data and transform my data further. And when it's done, this job has to be considered as completed and it never started again. Again, we have this kind of job here. And the command that I'm going to use is, of course, java-jar, start my job, like I would have done it on my local. And as argument, as mentioned before, the first argument is going to be the output CSV. Okay, where do you want to store this output CSV? And yes, output CSV is going to be stored at the location CSV report CSV. This might sound like file system, but it's not, because I made sure to use my volume, which is mounted to the path cs/CSV. And my report.csv is going to be further propagated to the persistent volume. And I'm accessing this persistent volume, as mentioned earlier, via the claim name CSV report, that persistent volume claim. So I am just using all the time the resources of Kubernetes to do the processing and also to store my data. Now going to the command line, apply -f, Kate's. Oh, sorry, forgot a thing. I'm using most of the time apply, and I forgot that apply doesn't work with the generated names. So now I have my generated name working, and look at the jobs. I think this one was the last one that I've created. Okay, so I have completions 4, parallels 2. And looking at my pods, I should have deleted what I had earlier. So I have 2 pods that were created like a few seconds ago that are running. And the other ones are going to be spinned off and run in about a few seconds once these 2 are done with their work. So you just need to wait for a few more minutes for the other 2 to be spinned off as well. Actually, I wait for a few seconds for the other. Okay. Yeah, so you can see here, the other 2 took a minute to complete, and now the others are being spinned off to run in to do their part as well. But of course, we want to make sure that things were written okay. So I want to be able to port my data from that volume and see what's over there on my local system. So I'm going to use a helper pod to copy my CSV, the one that was written to the location, just to give it a plain name like helper. I'm going to say that my CSV is expected to be at the level of the persistent volume. So if I'm going to look back to my persistent volume definition, I see that the path here is /sample. So my helper has to know about sample. And the claim name is the one from here, is CSV report. So I'm going to define it here. I create my helper. Kubectl create -f. Okay, it's helper. So my helper is going to help me to, get my data. Okay, the last 2 pods were also terminated, so my job is now complete. Has done all those things. So what I'm going to do, I'm going to say kubectl cp using my helper pod from the sample path, and it's going to have like report.csv here. And we're going to copy it to report.csv in my local. Now looking here, it did a lot of processing. So I didn't have this one before it was copied. And just really quickly, how you can make this job to run whenever you need it to be run. If you need to schedule it and for it to run like whenever, like every 2 minutes, for example, just gonna simply copy paste things from here, change the API version to v1 beta 1, and change this to cron job. Now I need to change this a bit and add the schedule time and the new specification. And I think we just got ourselves a cron job that is going to run this job every 2 minutes with no concurrency policy and not having the failed job history and keeping the failed job history limit to 3. Going back to what we just saw earlier, we saw that the parallel batch job can run in parallel an amount of work. So parallelism helps us to get our task to be done quicker if we are just knowing how to juggle with that. And we saw that 2 by 2, the chunks were processed. So you're instructing the orchestrator to further process the chunk at its level, and by doing that programmatically. So you are getting this part also. But in addition to this, the spec.schedule, it helps you further, like you saw in the schedule job, it helps you further to predefine a schedule. So if you need to have the fixed completion job counts that we did firstly to run at the specified amount of time, you just use the spec.schedule and the cron job specification. You can always have the ability to recover from failure by using the suspend specification or the starting deadline seconds. But in addition to that, the cron job Kubernetes object, it comes with the successful job history limit and failed job history limit. That this is helping you to have improved monitoring, to keep up with the jobs that didn't perform as good as you expected. And last but not least, some final thoughts, because I think I'm a little bit overdue with my presentation. Before going ahead and creating a job strategy at the orchestrator level, you should first assess what type of object would help you, and it should be run concurrently or not. I mean, you saw in the first part we didn't need to run anything concurrently. In the second part, we wanted to run it concurrently because it helped us more with our specific context. Secondly, the job and the cron job should have a predictable memory usage. So when you are designing these jobs, you should also have in mind how much memory they're going to use. The economy that you used to have before when you were designing your job applications is getting ported also at the level of the orchestrator. And you should pay attention also to how much memory your jobs, and especially your cron jobs, because they're scheduled, are eating throughout the time. And of course, pay attention to the fact that if something is happening with your job and is failing, you must have like a backup solution and handle the job failure. And you can do that by instructing Kubernetes on how to handle failure, or you can design your own strategy afterwards. And last but not least, if you have jobs that they can no longer complete, as I think that is my first job that I have demonstrated to you, you should delete that one because it can no longer complete and it cannot do its work. So it's just polluting your application and it's not helping you with much. thank you, everyone. This is where you find the code. I'm going to share the presentation. I'm going to attach it to this session, but I'm going to share it also in the Q&A and in the session how you can reach out the GitHub account with all the examples, and you can further investigate what I couldn't necessarily explain or share through coding today. Let me stop sharing.
I thank you. Yeah, it was insightful, and it seems that we have some additional time for our Q&A. And yeah, so encouraging our audience to post more questions. And yeah, we already have one. This one is from Evgeny Bashkevich. What are the main differences with the Spring-batch?
I think you're referring to the differences between the JavaEE and the Spring-batch approach. Well, because that would be
yeah, you could specify a little bit, but yeah, let's assume that was a question about difference in E and Spring-batch, right?
So I think it depends on the flavor and how you want to create your application. A lot of developers are more familiar with Spring, and they like to use Spring, while others prefer they prefer the JavaEE approach. But both of the implementations follow the JSR 352 specification. It's just that the differences are at framework level, but overall, you're still defining a batchlet, you're still defining your job, you're still defining the steps, and of course, the reader, the writer, and your processor. It's pretty much the same thing, but you're using different classes based on your framework, of course. And of course, when you're thinking to bring your batch job into the new world, let's say with the Spring Boot world and everything, you're upgrading your libraries, and you kind of get all the best-in-class parts of those new frameworks. And for example, I just got yesterday, while I was looking at my code in GitHub, on a security alert regarding the version of Spring that I was using, and Spring-batch I was using. I have one is high and the other one is moderate security alerts. So having old stuff, it gets you in a bad position when it comes to security most of the time. And the solution around these was to, upgrade. That's what the Dependabot told me, like, hey, please upgrade. This is a solution to make your code work. But I kept it like this just for the sake of, like you used to write it a long time ago.
Great, thank you. I'm marking this question as answered. Yeah, Sergey, maybe you have some more questions to Ana-Maria.
No, unfortunately, no.
Okay, then I have one. Ana-Maria, and yeah, I'm not a programmer, and but I'm really involved into community building and support for a long time, for maybe like the last 7 years or something like that. I'm in technical community. So my question is about the community, about your craftsmanship community. Could you please share a little bit more about the idea of craftsmanship? Because I remember that some time ago, like maybe 3 or 4 years, I was organizing a conference on craftsmanship in Minsk. Back in time when conferences used to be offline and people gathered together to drink coffee, So yeah, it was fun, but seems that I didn't I couldn't comprehensively bring the idea of craftsmanship to the community, and it was the one-off event. So the community wasn't like developing around the topic. So I'm interested in what is the main idea of craftsmanship, and what is the main value which unite people around this idea?
Well, the main idea that we wanted to have with this community, is to share what we learned. I mean, by all of us, what we learned, not just us, the founders, what everyone learned, and to make this approachable to our local developers here in Romania, and to share more of what you've done, not necessarily disclose what you've done for a specific client, but what you've done, what you've learned, what were you stuck with a specific technology. And this is why we said craftsmanship, because we didn't want to say that we're targeting a specific technology. We are not looking at the specific technology, given the fact that myself, not just on one thing, Victor is neither on just one thing. So in general, we want to leverage best practices in terms of programming, or best practices in terms of architecture. So it's more like a get together and sharing best practices, what you learned, and feeling that idea of improving of yourself by sharing with others or listening to others. It's more of learn together, pretty much. You become better by learning together, like in the conference type.
Sounds great. Maybe you could recommend some online rooms, platforms where people can talk about craftsmanship and all these things which can make you better in terms of your skills.
Okay. We have our own meetups. But in the world, I've seen that there are quite several craftsmanship communities gathered around the same concept of improving your coding skills by either live webinars, or by discussions, or I don't know. We used to have katas online and enjoy put people to participate. That's also one way to do that and engage with the audience. And yeah, it's pretty much it. And another idea that we had behind this one is to have it only online, so we don't have that many of in-person events, because a lot of people are busy, and we thought okay, people are busy and they're always going to say that we don't have time to do something because we're busy, and after work maybe you're tired. So let's make it online, and who wants to join, it's fine. Who cannot join can see the recording. So recently we started recording the sessions, and we also recently started to have sessions in English. Before we used to have sessions in Romanian, but now we thought of opening it up for people that are outside of the country and have also sessions in English, and see how that goes. We're still exploring that. It's not something that we've done for quite a while. And yeah, we're doing this whenever we find time. So it's not like a constant community present there. It's just whenever somebody has something to share, then we go for it. We're encouraging the speaker to share. And yeah, so we're not very constant, but we are hoping that by having this approach of not being constant with sharing and with the sessions is fine, and really give some time to people to breathe as well.
Thank you. Great. Yeah, another positive thing about going online is that you also go global, and lots of people can join together. Lots of people from different parts of the world can join together, yeah, and discuss their issues, or maybe share their experience. Yeah, and we have one more question from Christian. When batch partitioning with parallel execution should be preferred over launching different containers?
Well, I think it depends on you and your design. I mean, if you think that putting more containers to work, it will consume more resources at Kubernetes level. And my thought would be for you to try, by the way, I didn't have that much, I kind of went in a rush, but the first thing you should try with a fixed completion job and see its performance and how many resources it consumes. So if you want to see that, what are the benefits of having multiple containers? If having those multiple containers, it got you away from the burden of the Java application doing all the work and waiting for the next chunk to be processed, then okay, go with the containers. But it's also making you a little bit of aware, like how you're going to split the chunks for the orchestrator. So this is pretty much the catch. You have to think from the orchestrator point of view when you are putting Kubernetes to work. So think about how the orchestrator would think on processing that chunk of data, per each container. So it would be like having like 4 applications instead of one application doing 4 times the thing and 4 chunks of data and waiting for those. A good part of it, besides the amount of resources that it consumes, when you have 4 containers running at the same time processing data, is that you can get faster to a result, and you see that data being processed in a less amount of time than you would have seen it with just putting an application, Java application to work and sitting there and waiting for the chunk to go through that.
Thanks. And we have clarification from Evgeny. It's maybe an additional question. So it's just usual AE batch running on Kubernetes, right?
Kind of. I didn't have actually. It could have been too much trouble to put a more complex example. But if you are having a dependency of a specific runtime, because each application server in the past used to bring its own runtime and its advantages. But if you have dependencies to that runtime, you should take into account what dependencies to the runtime of your application server you had, and think on how you can put that at Kubernetes level. So it might have involved, by the way, some changes for your applications, so in terms of what the classes that you're using, so you don't depend anymore on that specific old runtime, and to be a little bit more agnostic. In my case, it was a simple application, and it was not depending necessarily on the server runtime. And it was easy with OpenLiberty because it's a small server, it's a small runtime, and it's easy to port it. But if you are thinking like in the old ways of doing things, or for example, if you're having a JavaEE 6 or JavaEE 7 application, it would be better if you would port that to something newer. And also the new frameworks, I could say that Quarkus is having also a good way of handling batch applications. If you're thinking of modernizing your batch to something that's more close to the JavaEE and it's not Spring, you could use Quarkus. You can also think at microprofile. So it's pretty much thinking of your batch of the atomic unit of work, modernized to work on Kubernetes. In my case, I was lucky to port it directly, and because I don't have that much time to leverage a complex example. But in real life, you can encounter these kind of dependencies with your application runtime. And it used to be this mirage with the application runtime dependency and use the facilities that your application server has. But in time, it brought more tight coupling to developers that were developing such kind of situations. And you can get to the same problems with, I think, with the Spring-batch. It depends in the end of your way of implementation or how old is your application.
Thank you. Yeah, it seems we were done with questions here. Thank you so much for your talk and for your answers. And we actually have a break now, and you can continue to chat with attendees on Spatial Chat. And for those of the attendees who have networking options, please go to Spatial Chat and continue there with speakers with Ana-Maria and with speakers from other tracks. Thank you so much. Yeah.
Thank you. See you.
See you. And for our audience who's still here, please don't miss our partners and their booths. They have great contests there. And yeah, you can attend 2 contests from Mira. They are suggesting you to try a coding challenge and to try to draw a monster, which sounds very exciting. And yeah, I think I'm going to do that myself. And you can win some prizes. Yeah, and see you soon in this track with the next speaker.
Okay.
Thank
Take
you.
care.
Take
Bye.
care. Yeah,
Thank you.
bye.